GCSE Physics boosters, stopping distance. Somebody having a bit of a problem with the car there. Now, imagine somebody's driving a lorry and they're driving pretty fast and they see a small child with a balloon in the middle of the road, as you do, and the driver thinks, "Oh dear," or words to that effect, and slams on the brakes. And then the vehicle comes to a stop within inches of the child. Phew. Okay, so this is all about how far they travel, stopping distance. And the stopping distance is made up of the thinking distance and the braking distance. Now, what does that mean? Well, the thinking distance is before they apply the brakes. So they see the child, they think, "Oh, blimey," and they press on the brakes and they travel a certain distance before the brakes are applied. And then the braking distance is after the brakes are applied. So how far they travel before they stop. And that's the total stopping distance is made up of those two. On a velocity time graph, we did this in a video a couple of videos ago, a velocity time graph would look something like this. Notice for the thinking distance, the driver sees the child, the brakes are applied, so they're still traveling at a constant velocity. Then I'm assuming that the deceleration is constant because the gradient is constant, so the graph goes down and the vehicle stops. How could you find the distance traveled in each of those? And you should remember that it's equal to the area. So the thinking distance will be a rectangle and the braking distance will be a triangle. What will affect the thinking distance? We'll talk about the braking distance in a minute. What will affect the thinking distance? Well, one thing is the reaction time of the driver. Now, typical reaction times between 0.2, 0.9 seconds. It's affected by tiredness, it's affected by alcohol and drugs, various drugs, also distractions. If you look at the photos down here, you'll know what I'm talking about. Okay. The number one thing will be the speed of the vehicle, how fast you're traveling. If you think about it now, how far would you travel in half a second, which is like a good reaction time? If you're traveling at 5 meters per second or 20 meters per second or 30 meters per second, how far would you travel in half a second? It's quite a big difference. How would you go about measuring your reaction time? There's quite a few ways of doing it. One way that I've done with students is now somebody holds a 30 centimeter ruler and somebody else puts their fingers at the bottom of the ruler, and then when the first person lets go, you have to try and catch the ruler. Okay, when you see it start to fall, you close your fingers, and then if you measure the distance that the ruler has fallen, you can work out the time, which is basically your reaction time. Okay. A few questions to think about. Why should you repeat the experiment several times, in fact quite a few times, and take an average? How could you calculate the reaction time from the distance fallen? And then lastly, how might you use a stopwatch to find somebody's reaction time? Well, now, why repeat it lots of times? Because there's a lot of uncertainty. If you did it 10 times, you're unlikely to get exactly the same answer. Okay, there's lots of random error, and if you take an average, what you're doing is you're minimizing the effects of random error. In other words, if some are too big and some are too small, then when you take an average, it cancels out the effect of random errors. To calculate the time, now, you don't need to know this equation. We do this equation at A level. I'm saying what it is here in case you actually want to do the experiment, but don't worry about this equation. The point is we can work it out, okay, using our SUVAT equations. How might you use a stopwatch? I'll leave that to you because I think it's pretty straightforward. Now, what will affect the braking distance? Well, now what we should think about is some of the physics that we've learned. To help us answer this question, what will affect the braking distance? Well, we did an equation, F equals ma, a while ago from Newton's second law. And basically, for a smaller braking distance, we want a larger acceleration or larger deceleration, which is a in this equation. So for the thinking distance to be small, basically, if the mass is smaller, something like a motorbike will have a much smaller braking distance than a lorry. A big heavy lorry traveling at 70 miles an hour will have a much bigger braking distance than a nippy little motorbike. Okay, and then there's F. F is the force slowing it down, which is to do with how many tires it's got, how good the tires are, okay, things like that, the condition of the road. We'll talk about that in a bit, but F equals ma has a lot to do with it. We can also think about energy. Okay, now the brake pads are actually providing the force to stop the wheels from turning, and then if the wheels stop turning, then a large amount of friction is involved in the brake pads, but also between the tires and the road. And then what happens whenever friction is involved, you've got energy being transferred into heat. So the kinetic energy of the vehicle is transferred into heat as work is done against friction. Why is the stopping distance likely to be bigger if, okay, so the road surface is wet, icy, or in poor condition, the brakes are in poor condition, the tires are in poor condition? How will that affect the stopping distance? Well, there'd be less friction. There'd be less friction between the tires and the road, and so there'd be less force slowing down the vehicle. How will the mass of the vehicle affect its stopping distance? Already said. The larger the mass, the bigger the stopping distance. And it's interesting, the effect if you've got passengers in the vehicle. You know, if you're driving a car and there's just you in it, or if the car's full of people, what difference it makes. And you do feel the difference when you're driving a car. If you have to brake suddenly, why might the brake pads not do their job properly? Why might the tires not do their job properly? And the brake pads may fail. If you brake suddenly, the brake pads may not do their job. They might actually catch fire. And also you may skid. And if you start skidding, then there's probably a lot less friction and you may lose control and end up going off the road. Okay, this is why you have on modern cars now you have anti-lock brakes, and that's supposed to stop you skidding. Okay, there's a lot less friction if you start skidding. However, the most important factor that will affect the braking distance again is the speed of the vehicle. Okay, if you're asked to write a list of things, don't forget the speed of the vehicle. For thinking distance, for braking distance, for both of them, the speed of the vehicle. When you do your driving test, you actually have to learn this chart. Now on this chart, the speeds are in miles per hour and kilometers per hour. I've put meters per second on there as well. Okay, now what patterns can you see? In blue, you've got your thinking distance. In red, you've got your braking distance, and then you can see the total. Okay, which of these statements are true? Your thinking distance is proportional to your speed. So in other words, if you double your speed, does your thinking distance double? And the answer is yes, because speed is distance over time. Okay, the overall stopping distance is proportional to your speed, and that is no. Okay, if you double your speed, if you look at from 20 to 40 miles an hour, you go from 12 to 36. That's 3 times bigger, not double. So it is more than proportional. Yeah, your stopping distance there's a big effect on your stopping distance by your speed. Finished with this slide here. At the end of the school day, small children, they just want to go home, have a snack, watch CBeebies or whatever, some rubbish. They don't realize how dangerous the roads are. And especially there's idiots on the road who break the speed limit. A few statistics there. In 2021, 120,000 casualties, 25,000 people were killed on the roads. How could you reduce that figure? There's one obvious way, isn't there? So obvious, I'm not even going to say what it is.